Let's have a transition moment, friends. You like this bell? Does this bell work good? I like the bell. It's like something you can hold on to and dive into. If you don't like the bell, send me a secret message. Tell me to stop hitting the bell. I'll do it. An anonymous tip. Send it to my department chair. Some of your students are very upset.
Bell's gotta go.
Cool. All right. Let's just come into this place after a long break. Love the fade out of the bell and the world's emergence. Quite lovely. Alrighty, so let's see, what's going on in this class? This is business calculus, right? MT 330. We've got a written assignment out, is that correct? Okay. Yes, I'm seeing one definite head shake and then some maybes. When was that due? Wednesday? Yeah. Do we want to talk about that? How are we feeling about that? I've got a feeling that one person has started this. Who started this? We're all friends here. Yeah. No, you started too? Cool. Is it going okay?
Yeah.
Okay, awesome. My friends who haven't started it, we could make it due Friday.
Yes,
Would that help you? Yeah.
Yes, I just didn't know it existed.
Yeah, that's what I got that vibe. Yeah.
Yeah.
It seemed a little shocking to you. Yeah. But you play it cool. Just play stuff cool in general. So, I will answer questions. You can turn it in on Friday if you need extra time. But if you can also turn it in on Wednesday, the original due date. And I believe that is in World Class, where you can find on the calendar. If you go to Wednesday, you'll see the homework, what you need to do. That'll be our first written homework. We're probably going to start having some quizzes next week because there's a bunch of new stuff that you need to integrate into your heart and mind, or just your mind if you don't want to put it in your heart. So no questions, ladies? We're good so far? Okay, cool.
I don't see the sorry to interrupt. I don't see the actual assignment form.
Go to the calendar? Or did I not put it in the calendar?
It's on there. Course home for sure.
Yeah, go to course home. And it's some problems out of the book. While you're looking for that, Mace, I want to just do a quick recap of what happened and then push forward.
And then click on the at the bottom, you will see the numbers of the.
Thanks, Lorelai.
Yeah.
Appreciate you. Okay, cool. So we've got 7 weeks left. We've got 14 meetings left together. Maybe less. They'll probably have a mental health day in there somewhere. So we'll probably have like 13 days. I might have to take a trip to help my mom out with some stuff in April. So I might have to cancel a Monday session, but I'll keep you well aware of that. We were talking about, so the last thing we talked about was limits, and then we started talking about secant lines and how they lead to tangent lines. And let's just review these two. If you take these two and add them together, You get that one. So these two concepts made the idea of a tangent line something we could work with. So I've got some curve, and I've got a y-axis, x-axis, y equals f of x, and I've got some point here. Let's call it, let's just call it x, why not? My plan, the thing I want is to figure out what is the slope of the tangent line there. Now, could somebody tell us what the tangent line is? Mace, I asked you this question via email, my friend.
Yeah, you answered my question with 2 questions.
Correct. That is correct, sir.
Yeah.
Yes. Did you happen to research either of those?
I one of the first questions was just what was the formula that we've basically been using, which didn't have a problem with that.
Okay. The other one was, what is a tangent? Because you're like,
yeah, what is the tangent
how do I do this
line?
problem with a tangent line? I was like, well, let's figure out what a tangent line is.
And if I'm being completely honest with you, I was going to wait until we met. to
I expect nothing else but honesty from you, so I
discuss.
appreciate
So,
that.
yeah.
Yeah, cool. All right, fair enough. Jack, what's a tangent line?
It's a line that touches the other line at one point.
Yeah, exactly. So it's a straight line that touches the other curve. It could be a line. If it was a line, it would touch at all the points once it touched. But a tangent line is just a line that touches our curve, just brushes it at one point. How does that differ from, so this is a tangent line right here. How does that differ from a secant line? Lorelai, how do you feel like up for that one? Okay, cool. Anyone else care to? Jack, I'll come back to Jack. Jack, right now.
Well, I think a secant line touches at multiple points.
Yeah, exactly. Yeah, thank you. So a secant line is a line that touches at more than one point. So if I had this curve here, and I had a line that went like this and touched at 2 points, that's a secant line. Jack, what's the connection between the secant line, a tangent line, and limits? Do you feel up for talking about that? Yeah. How does this become that up there? Let's make some points here. It's got x. Here's x plus h. You got a little distance here, h. What if I'm interested in the tangent line at x? What has to happen? So this is kind of approximately that tangent line, right? But it's clearly not. It looks like the slope's too low. Mace?
Is it just that you're including part of this, the secant line, so that it becomes only if you're cutting out part of it, so it only becomes like the tangent?
Yeah, the second part of that is great. Yeah, it becomes the tangent, but not by cutting out. Let's say that this point is fixed and this point moves. What do I have to do for this to become that up there?
H is equal to 0.
Yeah, so this distance between these 2 points shrinks to 0. So if I move these 2 points closer together, these 2 points get closer and closer. So if I make that x plus h even smaller, then I'm moving to there. And then as these two come together, it becomes, when they coalesce, I guess that's how, I don't know how to spell coalesce. It's a great word. Wish I could spell it. Anybody, that sounds good?
I know what you meant.
You know what I meant. When they coalesce, when these 2 points coalesce, it becomes a tangent line. The way we wrote this mathematically is that so first off, let's write a couple things up here. The slope of the secant line, seems like we definitely need some refresher about what happened, so let's do that. The slope of the secant line from x, f of x, to x plus h, f of x plus h. Let me draw that again. So what I'm saying here So I've got 2 points. These are my x coordinates, x and x plus h. And then I got this function, and that's f of x. And this is f of x plus h right here. And then I got good old secant. If you imagine that, imagine my drawing is better than it is. That goes through that point. How do I find the slope of that line? Somebody help me out.
Take 2 points.
Got 2 points, cool. Yeah, got 2 points. Got them both there. So how do we find slope in general? What's the basic idea? You don't even have to worry about that. What does slope mean?
Rise over run.
Rise over run. Yeah, that's a great way to think of it. So the slope equals the rise over the run. Slope is a key idea for us, so we really want to always be thinking about slope when we're doing all the calculus stuff we're going to do. Slope equals rise over run, and we can write that out as change in y over the change in x. And the change in y is the upper point, take f of x plus h minus f of x. So this distance right here, this is delta y over the delta x. That's this guy right here. And that's going to be x plus h minus x. And notice the bottom just becomes x, so we actually have this. And so that's how we could compute that right there. And that gives us the slope of that. Then Jack said something earlier, the connection between this and the point, the tangent line that hits at just one point is, we're gonna let this h, this delta x, this distance shrink to 0. So we're gonna move that point in. And watch what happens to the slope. And the way to write that mathematically is limit as h goes to 0 of this quantity, f of x plus h minus f of x over h. So what this means, and let's just write up what this means so that we still got it in our heads. This is the value, the slope of the secant line as h gets very small. That's what we're interested in. Very small becomes 0, but you can't just plug 0 in here. We took a look at that. I can't just plug 0 in here because then I'm dividing by 0. So the calculus means method. This means method. And so you can use this outside of math. There's some, does anybody listen to The Doors ever? It's like your grandpa listens to The Doors. Anyway, there's a line in there by the madman Jim Morrison. He talks about the cold calculus of reason. So it's just the method by which something is done. For us, the calculus is going to be specifically differential calculus. Let's look at that word. Differential, difference. So it is a difference, and we're seeing differences appear here. And we're gonna get into the beauty that this produces. Like right now, this looks pretty ugly to you. You just came back from break. You're like, oh my God, I hope we don't have these formulas all the time. Maybe you feel that way. If you don't, advising's coming up. I could help you pick some math classes for the fall if any of this is like kind of gets you jazzed. But this thing right here is going to be the heart of everything we do for most of the rest of the semester. This right here has a special name. It's called the derivative of f at x. So that weird definition right there is the heart of the calculus we're going to study. let's take a look at an example. And I think, and my friends who have finished the homework can tell me if there's something like this in there. Let's say I want to find the limit as h goes to 0 of f of x plus h minus f of x over h. So I'm taking that definition, and I need to know what f is to do anything. Otherwise, it's just, that's what it is. If f of x equals, let's do 3x squared. Make it a little interesting. Hell, this might even be one of your homework problems. Is it?
Similar.
It's pretty similar. Yeah. Yours might be a little bit more involved. Might have a minus x in there or something like that. Is that looking right, Hannah?
Yeah.
It's not exactly.
It's not the same.
Cool. Okay, awesome. Similar.
Yeah.
That's all we want. So what do? Step one is write out this. So let's find this quantity, the derivative of f at x, given this. So what we're going to do is write it out. So limit as h goes to 0, f of x plus h. So remember how this function works. And this is, knowing this, that this means this, helps you get this part. Because whatever goes inside these parentheses, I'm going to replace every single x with that thing. So f of x plus h, let's actually write this up, is 3. Look what's in the box, the expression x plus h. So I put that in parentheses here, squared. And then I work that through, so that's 3. I'm writing it without the box, nothing happened between these two. And let's just put that over here for a second. So this is equal to limit is 3 times x plus h squared minus f of x. F of x is just that formula, so minus 3x squared. And then that's all over h. Let me get that gunk out of the way. And tell me if that makes sense, if there's anything I can say, any confusion, you're not sure exactly what happened, and we'll talk. So now this guy here, now I gotta simplify, because Mace, did you have a question? It looks like it kind of.
I'm good. My brain was just trying to work it out.
Is your brain feeling?
Just because of the way that 3x squared was subbed in differently, so where it's like x plus h
still remained its own thing, whereas it was just 3x squared.
Yeah, and you know, a way to think about this is that this function here, if this is just a rhythm, so if I said, what is f of mace? It's 3 maces squared. So whatever goes in for x, whatever's in this parenthesis, I just plug it in for every single occurrence of x. It's just a little placeholder. And so right here I see the symbols x plus h. If you think about it a little less and just do it, it kind of unfolds on its own. Does that, yeah? See where I'm coming with that? Okay. So this, what was the first rule? When I said we're going to find a limit, what's the first step in trying to evaluate a limit? Anybody remember? Step 1. You got it, Jack?
Well, you're trying to factor out the bottom so that it doesn't become 0.
Yeah, you're thinking long game,
Oh, okay.
definitely, and that's right. That's exactly what's going to have to happen. But remember, we talked about a plan to find a limit. Step 1, do what? So let's say I have this limit. I ask you to find limit as x goes to c of f of x. What's the first thing I try? Let's play hangman.
Plug the limit in.
There you go, thank you. Plug and chug. Just plug the damn limit in. Good. Nobody got hung there. So the first thing I would try is look at where x is headed and just see, so try to plug the limit into f of x. So in other words, I'm just gonna find, does f of c make sense? And when I say make sense, what I mean is not dividing by 0, i.e. does it not give division by 0? And if it doesn't, that's my answer. If this thing doesn't look like this, something over 0, then I'm done. So this is bad. But if it's anything other than that, A-okay. And now right here, you can see that I'm gonna have that problem. If I plug in 0, I get 0 down here. If I let h be 0, there's a 0 in the bottom right away, so I see the trouble. If I put 0 in for the top, what does the top become if I put 0 up there for h?
0.
0. If I replace the h on top with 0, I just got 3x squared minus 3x squared. So for this one, plugging in 0 gives 0 over 0. So I got to do more work. If you get this, if you end up with 0 over 0, it's time to, and then this is where Jack was going. He was looking down the road, just seeing over the hills and far away, that we're gonna have to factor. We're gonna have to FOIL that sucker out and hope for cancellation. So the next step 2 is if we have 0 over 0, when we plug in, factor, cancel, and go to step 1. Plug and chug again. So that's what we're going to do here. And could you take a minute, my friends, and warm yourself up with a nice hot mug of this crap? Isn't that good? I shouldn't probably be in food service with that. Let's just take a minute and see if we can simplify that beast. Probably already got that cranked out, Jack. Assuming so.
Yeah, just
Okay.
one error.
Ah, cool. Yeah, that looks good. Yeah, that looks, something happened. Something got, let's see here. Yeah, oh, you're fixing it. Okay, got it. Yeah, it'll come out in the wash after you do that. I kinda hope I started recording.
Yeah.
Cool, awesome. I don't even know how you can tell that from there. That's impressive. I won't expect you to do this in a lot of situations, but I would like you to be able to do it in a simple quadratic with a problem like this, a problem like your homework. How's it going here?
Alright, I've gotten up to where we left off.
Okay, so FOIL that.
Okay.
So you take the x plus h, I would do a little scratch work, like right over here, x plus h, parentheses around it, squared, and then equals x plus h times x plus h, and then FOIL it.
Okay.
Does that make sense?
Yeah.
You know what I'm saying? Okay, cool. How you doing?
This was.
Okay, cool. Sorry, can I look? Can I get a little closer? My old man eyes aren't working. Oh, that's beautiful. Yeah, lovely.
Thank you.
Doing good here? I think so too, absolutely. So I got a little, let's see. Yeah. Oh, that's it, okay, got it, yes, yes. Okay, cool. Do you, alright, so let's, do you want a little help?
Yeah.
Alright, you So let's first expand out x plus h squared. So let's do a little scratch work. Write out x plus h in parentheses. Put parentheses around it, and then squared. And now let's write that equals x plus h times x plus h. Put parentheses around each of those. Yeah, like that. Beautiful. Now we're gonna FOIL this out. Does that make sense when I say that? It is times in it. So we're gonna do, we're gonna do first times first.
Okay.
Yeah, you with me now? Okay, then what does the O stand for? Yeah, FOIL. We're foiling.
Oh, outside?
Yeah, you got it. What does the outside look like when we take a product of the outside terms?
Like this?
So so these are the insides.
Okay.
These are my outsides. So you just did first times first. Now we're gonna do plus the O outside, so x times h. You see? And then what's the inside? There you go. Beautiful. Oh yeah, you're rocking it. Yeah, that's exactly right. And then we gotta multiply that all by 3.
Okay.
And does that make sense?
Yeah.
And we're gonna put that, yeah, good. And then minus this guy. Yep, and then all that over h. Solid. So your next step is to see if anything cancels here. So I would distribute that 3. We got 3x squared. And do you notice here, just a real quick thing, these are the same. Does that make sense? So we have 2 of those, right? Does that make sense? So I've got 2xh, and if I multiply it by 3, what do I get?
3xh squared.
3 times 2 times x. Oh, here, can I use your pencil real quick, just to go? So these guys combine to 2xh.
Oh.
Yeah, it's easier to write it out. I think I was saying too much. Then I take 3 times that.
So 6.
There you go, beautiful. Yes, lovely. And then we got plus 3h squared. And then minus the 3x squared. And then all that, yeah, exactly. You're seeing what's gonna happen. So put that over h. And then do the thing you just saw where those 2 cancel. And then factor an h out of the top and cancel it with the bottom. Yeah, that's, yeah.
I'm having a hard time.
It's okay, I'll stay here. I'll stay here with you. It's all good. So we got 6xh plus 3h squared
Okay.
over h. Yeah.
And then factor.
Yeah, now factor an h out of the top. So let's write h times parentheses. And then what's left inside?
6x plus 3.
Yeah, beautiful. Yeah, you got this. Oh, and that's still over h. Does anything cancel? Boom. Yes. Right on. And now we can take the limit. We're just gonna replace h with 0. And what do we get?
6x.
You just did it.
Perfect.
Yes, perfect
Thank
indeed.
you.
Yes, good work. Good work. All right. Let me get caught up with everybody here. Is there an eraser around? Y'all see an eraser anywhere? Because I don't want to smear it all over my hands.
Yeah, it's right there.
And then all over my, wow, I must have done that. I think I did that. Messing with me. Okay, let's go through this guy. So, anytime, I'll just tell you right up front, you're always going to have to simplify this before you replace h with 0. It's just always going to be the way it is. So we go through, I'm going to take this guy here, and I'm going to carry this along. So I'll make mine a little bit more official than what I've been helping everybody write through. And then I've got 3, and I FOIL out x plus h squared, and I get x squared plus 2xh plus h squared. And that's because I did this, and then I FOIL. FOIL's gonna be your friend. And so you get it out first times first, outer is x times h, inner is h times x. Yay, I was hoping you would show. Welcome back, my friend. Hi. Just in time.
The grand reveal.
What's that?
The grand reveal.
Yes, the grand reveal, indeed. So is this making sense? What happened here? Good? Cool. Lorelai, you're good on that too? Yeah, awesome. So I've got 3 times this thing minus the 3x squared over h. Now I'm gonna, if you be careful and go slow, it'll pay off with fewer mistakes. So I'm just distributing that 3 over h. And now I see something glorious. That, those two cancel. And that will also always happen. If you get to this stage and you do the cancellation, you want everything on top to have an h in it, because you want it to cancel out. And that will happen if you've proceeded with proper algebra. So then this is limit as h goes to 0 of 6xh plus 3h squared over h. Now I'm gonna, I could at this point just try the plug and chug again, but I'm still gonna get 0 over 0 if I let h equal 0. So that's not good. I still have to factor some more. So I'm gonna pull an h out of the top. In other words, factor an h out. So just pulled one of those h's away. Use parentheses, use lots of parentheses. Now I can cancel. And notice what I've done. I've actually canceled out the 0 part, the thing that's making the 0 in the top and the bottom. And so now I'm left with this. And now I can do plug and chug. I'm just going to replace h with 0, and I get 6x. And I'm good to go. And let's talk about what we just made. We just built something. We built a thing we can use for lots of different purposes. What did we build? We built a formula for the slope of the tangent line. So let's actually summarize this. Summary. We just found the slope of the tangent line to y equals 3x squared at x. So if I draw a little picture down here, and that formula is this: slope equals 6 times the x coordinate. Notice x is totally free there. So now, if I look at 3x squared, which looks like a parabola, I can find the slope at any point. So what is the slope at x equals 1? So at x equals 1, what is the slope of that tangent line? It is 6 times the x coordinate. So this has slope of 6. What is the slope of the tangent line at -1? Well, it's 6 times -1. So if I come over here and get that tangent slope, it's -6. Where is the slope 0 for the tangent? And this is kind of like the question you were asking me, Mace, that I answered with another question. When does the tangent have a 0 slope? What is a 0 slope? What does that look like?
2 points missing, please.
Kind of. So like if you were drawing a line, if I said, let me ask you this, let's have a little conversation, is that okay? Cool. Is that a positive or negative slope?
Positive.
Beautiful. What about that?
Negative. Neutral.
Yeah? What's a number for it?
0.
0. That's a 0 slope. No slope.
Yeah.
So, yeah, I like it. What did you say? I liked it.
Neutral.
Neutral. Absolutely.
I don't know,
Yeah, that's
positive
cool.
to negative, something like.
Yeah, oh, I got you. Yeah. Zero. So a zero slope is a horizontal slope. Where does that happen here? What x value?
0.
There you go. And that's how you answer that question you were asking me. I just look at the graph and I notice that if I take these slopes as I approach, get closer to zero, that looks pretty. And I also see that I've got a horizontal tangent line at x equals 0. So notice that the tangent slope equals 0 at x equals 0. And you could have found that from the formula. If I said, hey, here's the slope of the tangent at any x coordinate, when x equals 0, this equals 0. That is also a minimum for the graph. So let's also make that note, because that's how we're going to use this stuff. What we're going to do, here's kind of a big picture that I'll say a little over and over again. I'm going to give you a function, and I'm going to say, find the maximums and minimums of this function. And what you're going to do is you're going to take the derivative, which is going to tell you what the tangent slope is at any point, and you're going to find where it equals 0. Because if you're a maximum or a minimum, the tangent slope at u is completely horizontal. And so our routine will be, take this, find that quantity up there. Don't worry, we're not always going to do it in this most painful way. We're going to come up with like shortcuts that are going to be amazing and powerful. And it'll be like a new algebra that you've never seen before. And we're going to figure out what is the formula for the derivative, this thing we just found, and we're going to say, where does that equal 0? We're going to solve it, and it's going to tell us where maximums and minimums are. So that's kind of the big game plan headed forward. Let's practice. Let's practice in a different way, with a more visual way. Mace has had it.
Yeah, no, I'm done.
You're out, man. All right. Have a good one.
Yep.
So let's play a little game to understand this a little more. I want you to keep this association in your mind. Derivative of a function equals slope of the tangent. That's absolutely vital. If you keep this in your head, it's going to make so much of what happens for the next, month much easier. But it is actually, and it's essential you understand this. So let's say I had a function that looked like, how about, let's get our book out. Oh shit. Nah, these don't look very good. I'll just make some stuff up. So let's say I have a function that looks like this. And that is y equals f of x. I want to sketch the derivative. So in other words, what I'm going to do is I'm going to produce another graph right underneath here. And it's going to represent the slope of the tangent for each x coordinate. So this is the function itself. And here, y equals the slope of the tangent to this graph up above. So now let's look through here. What is the slope of the tangent right there? And here's what you need to do. Imagine yourself, take your pencil in your mind or on your paper and let it ride on the curve. What is the slope of my pen?
0.
0. Do we see that? So right there, at this point, the slope is 0. So I'm going to put a 0 right there, because the output here is the slope up here. So we have a horizontal slope, Got a 0 value down there. Is this a positive or a negative slope? Lorelei, what do I got here?
Positive?
Positive, beautiful. And what's happening to it as I get this way? So it's positive. Is it becoming less positive? Is it becoming smaller, the steepness, as I move this way?
Yes.
Yeah, so check this out. So here we've got a steep positive, like maybe, let's say here that M is like 5 or something, the slope is 5. But as I move over this way, the slope is a little mellower. So like right there, the slope is maybe 3. And then as I come into here, that looks like it might have a slope of 1 right there. So I'm going to represent that down here in the same spot. So this one had a slope of 5. So over here I could put a 5 as the slope, and I'll put a little dot for it. And then as we move toward this, that slope headed to 0. So this is if you can do this, you've really gained some understanding. What happens after the, do you mind if can we keep talking?
Sure.
It's cool, awesome. So what's happening to the slope as I move this way?
It's becoming negative?
Yeah, it is becoming negative, definitely. So that means it's kind of dropping underneath here, like this. Where is it the most negative?
Would it be right there?
It is, right there, yeah. So right at this point, it's the steepest because here it's headed down, and then it maxes out its steepness right there and starts to become less steep as I move this way. What is the slope right here, Lorelei? And I'll let you be free after this, my friend. But what's the slope right here? Tangent slope.
0.
0, beautiful. So let's mark that off. So right here, at this point, the slope is 0. Let's think about what that did. So here we have a slope of 0, here we have a slope of 0. And as I moved from here to here, it gets negative. This is the most negative it can be, and then it starts to move back up to become less negative. So what we see in here is something like this. Right in the center is where the steepest part is. So here we have the most negative tangent slope. Thank you, I really appreciate your help on that. And then as I move away from this horizontal tangent, it becomes positive and more positive, gets steeper and steeper. And so it looks like this. So this graph represents the tangent slope on that graph. And this is the graph of the derivative. Derivative is tangent slope. So what we have here is the graph of the derivative. And I'm going to give you some notation. The derivative of the function up above. Here's the notation we use, i.e. f with a little accent mark, so like an apostrophe, we call that prime of x. So this symbol right here means the thing we just did. This is the tangent slope function. So this is the derivative of f of x, and I could also read that as f prime of x. So this thing is read as a little prime. That's the word for it. So now we got calculus cooking. So I would like you to try to do this now. I'm going to give you another graph. If you wouldn't mind doing the same thing, that would be beautiful. How's our time looking? Time's looking great. And then I think what we'll do is take some time. Let's see, is there also an online assignment?
There's nothing posted.
There's nothing posted online. There will be. Something will open up. Something opened up about 20 minutes ago. So there's a new online assignment. It's pretty short, but it's honestly this. It's what we just do here. So let's practice one together. my friends, I'm gonna give you a graph of a function, and I would like you to sketch its derivative. So, nice and chill. And what you need to do, I would make the graph right underneath so you can kind of sync up. Imagine the slope of the tangent and plot it out down below. Give that a shot. I'll drink tea. Trying to cut back on the jelly beans. I didn't bring any in today. A little out of control. Starting to worry about diabetes. Yeah, I don't want that. Not from jelly beans, you know.
I don't think anybody wants it from anything.
From anything. But to get it from an obsession with jelly beans is just dumb.
It's honest. It's extremely, extremely honest.
So this one's a little, there's a kind of a challenge here. It's a little challenging. Let me take a look and see what's going on. Jack looks like he already cooked it up. Oh yeah, I trick you. I got a good one for you, Jack. I got one more for you. Yeah, that's right, buddy. You know, go slower. You don't want more work. Slow down.
Be like the rest of us. Struggle. Ollie's done and out.
Straight lines. Those are straight lines, and that's a sharp point. Okay. Set up. It's this. So imagine in your mind little tangent lines across here. Okay. And what we're trying to describe down here is the slope of those lines. So, is that first off, are these lines positive or negative slope? They're positive, definitely. As I move from left to right, what happens to the value? Yeah, right on. So all I have to really do, and like, what is it over here? What is the slope of roughly over here?
0.
Yeah. Okay, so if I make it low, so this is my slope. Axis, here's x. So it's 0 over here. As I move to the right, it gets larger. That's all we gotta do. That's it. Yeah. You're freaking yourself out. You got this. Yeah, it does. So it does. So this.
Amy got you?
Yeah, cool.
Or are you
Let's
just
talk
playing
this.
along?
So
actually,
what we've got here is so what is the slope of all these lines? Is it positive or negative? Yeah. It's all positive. So down here, this should be above because this axis represents the slope. Yeah. So what is, and right here I see you have 0, so that's beautiful. It's like 0 right there. What happens to it as I move to the right? Does it become positive, more positive, right? So how would you indicate that down here? The slope, the output becoming.
Wouldn't that just be like the same thing?
Exactly,
Oh.
exactly. You got the flip of what it should be. Yeah, does that make sense?
Yeah.
Cool. Hello, my friend. How's this going for you? Not good? Okay, that's okay, that's okay. Make sure to just check out the recording from that first part of class, because I think there's some stuff in there you're gonna wanna see. Fancy your nails. Well, your nails are beautiful. You're welcome. So good, you got that the tangent slope there is 0, good eye. Is this a positive or a negative slope right there? Is it really steep? It's not, it's kind of low, right? Like half or a quarter or something. What happens as I keep moving to the right? Yeah. So think of this as that tangent slope. As I move to the right, it just becomes more positive. You don't have to, there's no precision here. It's more the general feel of it. Is that sinking?
Yeah.
Yeah?
Yeah.
You sure? Okay, you're not lying to me. All right, good. Give that guy a try now. Give the challenge. What how we doing here? Oh, that's beautiful. Gosh. Yeah, lovely. I love that you're working on it. I used to do this all the time too. Just like whatever scraps I got. I like it. What are we doing here?
Questionable.
Cool. I appreciate the honesty, just like my diabetes.
We don't have diabetes.
Okay,
yet.
alright.
Yet.
Jeez, my jelly bean based illnesses.
Moderation.
Yeah, moderation's the thing I'm working on it. So, can I see your pencil?
Sorry.
It's okay. So down here, so like right here, that's like a low positive slope.
Mm-hmm.
Yeah, so underneath, let's put down here, I'm gonna put slope. So right there, the value of that slope is a small positive number.
Mm-hmm.
What happens as I move to the right? You can
Gets
see
bigger.
it gets bigger. So all I have to say is the slope gets bigger as I move to the right.
Oh, I think I misunderstood.
I think a lot of people did. I don't think you're alone.
Oh yeah. Yeah. See.
Does that make sense?
Can you just re-explain in words one more time?
Yep.
Like,
We are
I'm
just, so
struggling
all we're
with this.
doing is we're trying to make a graph
Mhm.
that tells us what the slope of the tangent line is at any point down here. So this graph represents the tangent line slope up here.
Oh, okay, that would explain the empty graph.
Absolutely.
Yeah.
Cool. Cool. Let me give that one a try. That one's tricky. That's a tricky
Who
one.
did this?
Let's see if Jack got it. Oh.
Who
Is that
these
right?
lines?
Yeah. Now now you can see you made a big mistake, buddy. Now I gotta give you something else. No, I'm not gonna torture you. That's good. We're good.
Oh.
You
You
you didn't have to. It's okay. But let's do it. Let's do the second one. Let's do that second one over there. Imagine these are straight lines too.
Actually, go.
What's it? What?
Oh, wait, it can wait.
Oh, okay.
Not like not important.
Okay.
Not
All right. Wednesday will probably be a lot of, we'll just do some working on Wednesday and make sure everybody's, the work days, do we like this? Having time to work in class?
I appreciate it.
Okay, awesome, cause I like to be able to help and consult and give Jack a day off. Okay, oh, so tell me.
That's not a good.
Okay, so this is the tangent. So can we draw the original out, or is this the original? I don't think that.
It's not.
Okay, good. I agree too. I'm glad we both agree on that. So let's make the original. Nice old straight line. Yeah, just a V. Perfect. Okay, cool. So we're doing in a mind. Tangent slope. What kind of number is that? Negative. As I move, does it change? Doesn't really change, right? So let's make underneath. Down here, here's my slope. What would that look like down here? So I've got a negative. We agreed it's like negative. Let's say -1 or something, right? Why not? As I move to the right, what happens? If it got smaller, it would do that. Does that make sense? Because that's see how the slope's changing there? Slope's not changing here. In fact, the tangent line kind of just falls on the thing itself when I try to draw it.
Okay.
So if the tangent line here is -1, what's the tangent line here? What's the slope of that? Yeah, so it's the same all the way across.
Oh.
Yeah?
Yes.
See?
Let's see.
Finish, my friend.
So wait, would it just be straight across?
Well, you tell me. Is this a negative slope over here? No, I don't think so. Yeah, it's good. Don't worry about the 0 point. We'll talk about that sharp point, but work on the right side. What does it look like, the slope is over there? It's positive. Does it change?
No.
No. So what would that look like down here? Yeah. Yes.
Just a line?
Yes. Yes.
Okay.
Good work.
That was it.
Oh, that was like, that's just stunning.
Actually.
Yeah, congrats. You did great. Oh, look, you got it. It doesn't take, yeah, you're like instantly there. Impressive. Yeah, you're still working, I won't. Do you need help or you wanna think a little more? Do you need?
I could take a bit of help.
Okay, you got it. I am offering eternally. So, tangent line on this. Kinda looks like it just falls on it, right? Is that a positive or a negative?
Negative.
Yeah, so let's just put up, let's say that's, -3, and we'll say that's -3. Kinda helps to line it up. So we'll say, looks like maybe -1, the slope. And so I'll put it out there. Now as I move to the right, what does the slope become? So what's the slope here?
It's still the same.
It's still the same, right? So what does this look like as I move this way? Does the slope change as I move to the right? No, it stays constant. Yeah, I did a real shitty job there, but yeah. And then what about on this side?
So it'd be right there.
Yeah,
Okay.
it just jumps.
Okay, cool.
Yes, beautiful,
Understood.
beautiful,
Thank you.
wonderful.
I heard the word jump, so I'm going to,
Yeah, good, let's talk. Yeah, you're getting some cool like figures drawn there. Let's do them above, just so we got a little scratch right there. Okay, so what is the slope right there? Nice. Negative. Negative, yeah, let's say -1, right, just for the hell of it, sure. So here's -1, and that's our slope. So right there, got a slope of -1. What's the slope right there?
-0.5.
How you getting that?
I was just, it's moving closer back.
So look, so I think you're looking at the wrong thing. Imagine in your mind the tangent line through that point. Now the tangent line happens to fall on that line. So if this is just a line here, tangent line there is the same as the tangent line there, is the same as the tangent line there. It's just constant. It's constantly -1.
Oh,
You see?
yeah, because it's not, the line's not curved. it's
Correct,
just
that's
constant.
correct.
Sorry,
Yeah, that's all good. What about on the right side?
Same thing,
Yeah, but,
but going upwards, positive form.
positive. Always constant. Always +1. No matter where I check, it's got a slope of 1.
What would it be? Is this?
And then, yeah, we'll talk about that, guy. We'll talk about that. Alrighty, friends, let's.
That little guy, I would worry about that little guy.
What's that?
That little guy, I would worry about that little guy.
Yeah, we'll worry about that little guy here together, because that's actually, that's a heavy thing that we'll talk about, that little Sharpie. So, when we do this one, we imagine, just in your mind, the tangent line, or use your pencil, or draw them. But here I have a slope of approximately 0. So a lot of people put a dot there. That was great. I saw so many people getting this started off. It's not exactly 0, but it looks freaking close enough, so we'll put a dot there. As I move to the right, approaching the y-axis, it grows. So it becomes more positive. Like right there, it's almost like a slope of 1. So what I see is this thing just growing gradually to 1. Don't worry about the exact shape. You want the feel of this thing. And then it just keeps growing and gets super positive as I move this way. So these two graphs kind of look the same. Everybody seems to have gotten that. This is a tricky one. When I do this one, on the left, it looks like no matter where I take the tangent just falls on the graph. And it's always on the graph because that thing's a line itself. So if the slope here is -1, then down here, I'm gonna mark off a -1 and say, okay, there's my slope. And as I move towards 0, that never changes. Now I'm gonna put an open circle here at 0, because what is the tangent line here? So what is the tangent line here?
0.
It could be 0, but it could also kind of teeter right? Just think about it. You've got like a sharp little point like this. Mace,
Yes, sir.
please make a point for me. Let's check this out. I appreciate your help.
Of course, this is probably the best I'll contribute to this.
You're doing great. Can you rotate this way so everyone can see? So it's at a sharp point, the tangent, notice I can rock it back and forth.
You gotta get
I got
didn't
you.
move.
No, it's
I
not
did
your fault.
move.
Okay, I know it's my fault. Notice how at a sharp point, the tangent line can have any slope. It can just pivot back and forth. So there is no tangent line here there's infinitely many tangents that could work here. All those lines just touch at one point. So what we say is the derivative doesn't exist there. And what you need to keep in mind is the derivative doesn't exist at a sharp point. That's all. Just keep that in mind, that at a sharp point, the derivative does not exist. Does not exist. So we'll use that DNE just like we did with the limits. And then after I move across 0, it just becomes a positive slope, let's say +1, forever and ever. So I just put open circles there, got 1 there, and I've got this step function, this discontinuous thing. It just jumps up as I move across 0. So these ideas from today, this is that whole online homework. And if you could take a look at it, actually do the written homework first, get on that. Let's have Wednesday be a day of work and consultation. And you've got 2 assignments, right? 1 online, 1 written. Does this sound good, friends? Cool. I'll hang out if you want to work. You can do as you see fit. If you want us to keep working, we got 8 more minutes together. Ooh. Yes.
Can I consult both my schedule and my work schedule and get back to you on some times when we could be able to possibly meet?
Yeah.
Okay.
Yeah.
Cause my my schedule, like kind of not school schedule, work schedule kind of shifted.
Yeah, yeah.
So I'm hoping, fingers crossed, that like it'll allow. In theory, it should give me a lot more time.
Yeah. So like generally on Mondays and Wednesdays after our class, I have office hours. I don't know what you have after this.
I have this Mondays and Wednesdays and Wednesdays because I have 3 consecutive classes from now. I mean, it's not terrible. I don't want to shit.
You got an 11 o'clock.
I
That's
have
crazy.
class. Yeah, I have class from now all the way up until 1:45. Like I'm in class until.
Yeah, I got you.
Tuesdays and Thursdays, I don't have class until 12:30.
Yeah, and on Thursdays I can meet by Zoom lots of different
Yeah,
times.
any of those days, like, doesn't have to be in person. I
Okay.
obviously can do Zoom meetings.
We can definitely, like Zoom, I can make lots of things work on Thursdays.
Okay.
Does that sound good?
Yeah, I do have in terms of work schedule, I don't work on Wednesdays